Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 11, 2025, about 2 weeks ago. The big idea is a selective contrastive learning framework that reliably shifts model attention away from class-specific but non-affordance cues and toward the exact object parts that enable actions. The paper is titled Selective Contrastive Learning for Weakly Supervised Affordance Grounding. And as we will see later, the implications for model training are quite significant. In short, the method uses clip-guided object discovery plus adaptive, prototypical, and pixel contrastive learning to improve weakly supervised affordance grounding, especially on unseen objects. Also, the author shared a GitHub repo. It includes an MIT license, a README, and pre-trained checkpoints for AGD20K seen and unseen splits, plus HICO IIF. The README notes that source code will be released soon. You will find basic project info, authorship, and links to the paper, but no training code yet. On Hugging Face, you'll find the Selective Contrastive Learning Affordance Grounding Model, MIT licensed. No parameter sizes listed. Expect code snippets and examples for training and inference. Alright, the introduction set the stage. Figure 1 illustrates the workflow and what success looks like. The top row shows weakly supervised affordance grounding, where an egocentric image predicts the affordable part given an action label, with cues transferred from exocentric examples. The lower panels depict part discovery in both views and a reliability check that switches supervision. Reliable parts drive part-level learning, while unreliable parts trigger object-level cues. The comparison at the bottom highlights broader clue usage than the locate baseline. Earlier, the introduction outlined the workflow. Figure 3 illustrates object discovery with an egocentric view and complementary exocentric examples. The diagram shows clip image and text encoders producing an object affinity map, which highlights regions likely tied to the action class hold. The heat maps provide soft masks that guide selective contrastive learning, so activation stays on relevant objects rather than background. This setup matters because reliable object cues enable either concentrated part learning or, when parts are uncertain, safe expansion to the whole object. Alright, the previous figure highlighted object discovery. Figure 2 shows the overall training flow that connects egocentric and exocentric views. The dyno encoder extracts features that feed a small multilayer perceptron and projection heads, so the system supports both classification and selective contrastive learning. The classification branch predicts the action because it uses cross-entropy, while the contrastive branch aligns or separates features using prototypical and pixel objectives. This pairing lets supervision expand to the object when parts are unreliable, or concentrate on precise parts when reliable cues exist. Alright, the earlier figure outlined the training flow. Table 1 reports head-to-head results on AGD20K, seen and unseen, plus HICO IIF. The method ranks first across all splits, with the lowest KLD and the highest SIM and NSS, which indicates sharper and more accurate affordance localization. The gains are largest on unseen objects, so the selective contrastive objectives generalize beyond training categories. Baselines that combine dyno and clip and even large language model toolchains trail the proposed approach. Okay, wrapping up, 2 takeaways stand out. Selective prototypical and pixel contrastive learning steers attention from class bias toward true affordance cues, and the object-to-part switch guided by CLIP maps delivers strong generalization to unseen objects. The gains across AGD20K and HICO IIF back this up. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.